student, hope you are doing great and welcome back to the Manzu classes. Now I am very sure that you are excited to learn the new topic today. Yes, so let's quickly recall what did we do in the last video first of all. So we talked about the cube numbers. So what are cube numbers? The numbers that can be expressed as the product of a number multiplied thrice. So here you can say that if we want to find the cube of 5, then 5 times 5 times 5. Which is equals to 5 cubed, and 5 cubed is 125, which is a cube number. Is that clear now? And I hope you remember this. Now let's go ahead and think over one question more. And that question is, without actual multiplication, find 8000 is a perfect cube or not? So this is a hardest question. Do you think so? Right? So if we have to find, we do it like this. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. We just know this method only if we want to get to know that if this number is a perfect cube or not. But here, now this time we have a challenge that we need to do it without actual multiplication. How are we going to do it? So don't worry, I'm going to teach you this thing only in today's video. So let's go ahead with it and let's get the answer to this question. Okay. So now the topic for today is interesting pattern in perfect cubes. So in this lesson, we will be talking about two interesting patterns majorly. One is adding the consecutive odd numbers and then cubes and their prime factors. So let's go ahead with the very first one, which says adding consecutive odd numbers. It says observe the following pattern of the sum of odd numbers. So here we can see that we are taking just one number, okay, one odd number, and this is one cube. Then I'm taking the sum of next two odd numbers, okay, next two consecutive odd numbers in fact. So I'm getting the cube of 2. Then I'm getting the sum of next 3 odd numbers, okay, and again keep it in mind that we need to take the consecutive odd numbers, and then I'm getting the cube of 3. The next 4 odd number sum is going to give me the cube of 4, and then the sum of next 5 consecutive odd number is giving me the cube of 5. Now what if we want to calculate the cube of 6? Then I am going to get the next 6 consecutive odd numbers. And what are these going to be? After 29, the next odd number is 31, then 33, then 35, then 37, then 39, then 41. Here how many cube numbers? 1, 2, 3, 4, 5, 6. I've written 6, and then the 6th cube is 216. Is that clear now? What is the pattern of consecutive odd numbers over here? Now, what if I suddenly ask you that, now if you want to get the 8 cube, then which 8 odd numbers are you going to add? Okay, now you do not have any place to see this all pattern. So you just directly have to tell me that from which number are you going to start with? So don't worry, I'm going to answer this question also, okay. Then it says express the following numbers as the sum of odd numbers using the above pattern. Now the pattern which we learnt in the previous question. So here we want to get to know that from which number are we going to start, and then which 6 odd numbers am I going to get. For that I have the formula n multiplied by n minus 1 and then plus 1. Now here what is n? That is 6. So now 6 multiplied by 6 minus 1, and then we need to add 1. So here 6 minus 1 is 5. So 6 multiplied by 5 is 30. 30 plus 1 is 31. So that means I am going to start the odd numbers from 31. 31 plus 33 plus 35 plus 37 plus 39 plus 41. 1, 2, 3, 4, 5, 6. Here I have taken 6 odd numbers. Is that clear now? So this is going to give me the cube of 6, which is actually 216. Okay. Now Here if you have to calculate for 8 cube, then which number are you going to start with? We know that n multiplied by n minus 1, that means 8 multiplied by 7 plus 1. So 8 times 7 is 56 plus 1 is 57. So that means I am going to start the odd numbers from 57. Okay. Now let's quickly take the sum of the consecutive odd numbers, right? 57 plus 59 plus 61 plus 63 plus 65 plus 67 plus 69 plus 71. 1, 2, 3, 4, 5, 6, 7, 8. 8 odd numbers are there, and this is going to give me the 8 cube over here, and this is also equals to 512. Okay, so let's quickly go with the next pattern. It says the subtraction pattern. So let's see what is this pattern. If you see over here, we are calculating the difference between the two consecutive cube numbers. Okay, so 2 cube minus 1 cube, 3 cube minus 2 cube, 4 cube minus 3 cube. You know what, this also follows a pattern. You can see that here we have numbers 2 and 1, so I am multiplying 2 and 1. Here we have number 3 and 2, so I am multiplying 3 and 2. Here we have number 4 and 3, I am multiplying 4 and 3. You can see that in the beginning, everywhere I have 1 plus 1 plus 1 plus, and at the end I have multiply 3 and multiply by 3. Now for example, I have to do 5 cube minus 4 cube, then what will we do? So here we can say that 1 plus 5 multiplied by 4 multiplied by 3. So 5 times 4 is 20, 20 times 3 is 60, 60 plus 1 is 61. So you can say that here the answer is going to be 61. So this is the pattern it follows. Okay. Now what if we have to calculate the value of 7 cube minus 6 cube? Then again 1 plus 7 multiplied by 6 multiplied by 3. So now 7 times 6 is 42. 42 times 3 is going to be 126. So 126 plus 1, which is going to give me 127. So here the answer is 127. So this is the pattern that we follow here to find the difference between two consecutive cube numbers. Okay, let's go ahead, and it says the cubes and their prime factors. Now we will be talking about the prime factorization. You remember we learnt it in the last chapter. How can we do the prime factorization? Yes. Now 4 cube is actually 64. Now we will be actually looking at the prime factorization of 64. Okay, when actually you will be solving it, this is what you are going to get. Okay. When we used to talk about the square numbers, we used to take the pair of 2 numbers. But when we talk about the cube numbers, then we take the group of 3 numbers. Okay, this is one group, and we can say that this is another group. Okay, and similarly in the next one, if you see here, also we will be taking the group of 3 numbers. Okay, you can see group of these 3 numbers, and then the group of these 3 numbers. So here each prime factor of a number appears 3 times in the prime factorization of its cube. Okay, now let's say if we are talking about the prime factorization of 4, this is only 2 times 2. Okay, now if we talk about the cube of 4, then each prime factor is going to repeat 3 times. 2 times 2 times 2, and then again this is also going to repeat 3 times. 2 times 2 times 2. Is that clear now? Okay, now let's say here the prime factorization of 15 is 3 times 5, right? Now the prime factorization of its cube is going to be 3 times 3 times 3. This also is going to repeat 3 times. And then 5 is also going to repeat 3 times. So this is how prime factorization of a cube number looks like. Is that clear now? Yes. So let's go to the next question. It says, is it a perfect cube? If not, make it. Now let's quickly check out the prime factorization of the number 15, which is 3 multiplied by 5. Then the prime factorization of a number 30. I hope you remember how to find the prime factorization. Like this, 30, we can divide it by 2 and then it's gonna be 15. Then we can divide it by 3, it's gonna be 5. And then we can divide it by 5, it's gonna be 1. So here we have gotten 2, 3 and 5, right? So this is going to be the prime factorization of 30. And then the prime factorization of next 15 is 3 times 5. Now, what are we going to do? We are going to group the numbers. Now here we can see that we have 3, 3 and 3, right? We have 3 times. And then let's check 5. 5, 5 and 5. So we have 5 also 3 times. But if we see this 2, this is alone, right? So that means this is definitely not a perfect cube, right? Because this 2 is alone. So if I want to make it a perfect cube, then for that I need this also 3 times. So let me take this 2 times more so that I can complete the group of 3. Right? So now I have 2, 2 and 2 and then I have completed this group also. Okay. So here I am taking 2 2's extra, right? So that means 4. So if I will multiply it by 4, then this is going to become a perfect cube. Is that clear now? How can we make a perfect cube if the number is not a perfect cube? Yes. So let's think about the question that we had in the beginning, that without actual multiplication find if 8000 is a perfect cube or not. We can check the prime factorization of a number 8000. Okay. So let's quickly divide by 2 first of all. We will get 4000. Then divide by 2 again. We will get 2000. Then divide by 2 we will get 1000. Then divide by 2 we will get 500. Then divide by 2 we will get 250. Then divide by 2 we will get 125. Now we can divide 125 by 5 and we are going to get 25. And then again divide by 5, we are going to get 5. Then 5 divided by 5 is 1. So here 8000 is equal to 2 times 2 times 2. Then times 2 times 2 times 2 and then 5 times 5 times 5. Now we will actually see if each prime factor is repeating 3 times or not. Now you can see that this is one group, this is second group, this is third group. So then we can say that yes, this is a perfect cube. Is that clear? And there is one more way to check it. You know what? We can write this 8000 as 8 multiplied by 1000, right? Now we know that this 8 is a cube of 2 and then this 1000 is a cube of 10. So when the base is same, what will we do? We will multiply 2 by 10 and the power is going to be 3. So we can write it as 20 cube also. Is that clear now? So this is how you can check if a number is a perfect cube or not. Let's quickly practice some question. It says, is 392 a perfect cube or not? If not, find the smallest natural number by which 392 must be multiplied so that product is a perfect cube. So let's quickly check if it's a perfect cube or not. Okay, we are going to check its prime factorization. So now we will divide the number by 2. Okay, we are going to get 196. Okay, then again divide by 2, we are going to get 98. Divide by 2, we are going to get 4 and then 9. And then we are going to divide by 7. And then we are going to get 7 over here and 1 over here. So now here the prime factorization says 2 times 2 times 2 times 7 times 7. So here we can see that here we have the group of 2, right? The 2 is repeating 3 times, but 7 is repeating just 2 times, not 3 times. So definitely this is not a perfect cube. Then if it's not a perfect cube, then find the smallest number by which it should be multiplied. Of course, we need to complete the group of 7 also, and that is going to be the smallest number that should be multiplied to make it a perfect cube. So we need one extra 7, right? So we are going to multiply 392 by 7. And then what is it going to be? Let's quickly multiply it over here. 7 times 2 is 14. Then 7 times 9 is 63 plus 1 is 64. 4 here, 6 here. 7 times 3 is 21 plus 6 is 27. So we can say that 2744 is a perfect cube. Is that okay now? So let's go ahead with the next one. It says, is 1188 a perfect cube? If not, by which smallest number it should be divided so that the quotient is a perfect cube? So let's quickly check the prime factorization of 1188 first of all, okay? Then we can divide by 2, 5, 9, 4. And then again divide by 2, we are going to get 2, then 9 and then 7. We cannot divide it by 2. So we will quickly check if we can divide it by 3 or not. Okay. So now if I check it, yes, we can divide it by 3, and if we divide it by 3, we are going to get 99. And then if we divide it by 3 again, we are going to get 33. If we divide it by 3 again, we are going to get 11. Now here 11 divided by 11 is 1. So let's quickly check the prime factorization of this number. 2 times 2 times 3 times 3 times 3 times 11. Now here I can see that I have 3 which is repeating 3 times, but 2 is repeating just 2 times, and here I have 11 only 1 time. So here it says, if not, then by which smallest natural number should be divided? So what are we going to do? We are going to eliminate this and this, okay? 2 times 2 is 4, 4 times 11 is 44. So we are going to divide this number by 44, and then the number that we are going to get is going to be a perfect cube, okay? And now we will divide 1188 by 44. And after division, this is going to give us number 27, which is a perfect cube. Okay. So let's summarize what did we learn today. We learned about interesting pattern. First of all, we talked about adding the consecutive odd numbers, right? And then we talked about cubes and their prime factor. So each prime factor in the cube number repeats 3 times, remember? And then after that, we learned what is the smallest number that we should multiply by number to make it a perfect cube, and then also we learned that what number we should divide by to make a number perfect cube. So this is all we learned today. I hope you understood everything, and in the next class we have many more things to learn about the cube numbers. Okay, if you are excited, then see you in the next video. Till then, take care of yourself and bye bye.